The training program you're about to view is one of our classics. Even though it may have been taped years ago, it still shows expert linemen providing professional work practices. Make it a point to always follow the established work practices of your company to help in your safety and the safety of your coworkers.
Gulf States Utilities Company of Beaumont, Texas, needed a new 230 kV transmission line from their Lewis Creek generating station to China Bulk for the purpose of serving as a system tie line. The A.B. Chance Company full-service engineering staff was called in for recommendations on structure-type hardware and maintenance that would possibly meet Gulf States' demand for long-term, uninterrupted customer service and utility at the most economic investment level. This structure, with planned maintenance engineered into it, was recommended and implemented. Here's how the maintenance is accomplished. Let's begin with this dead-end structure where the line crosses the old Beaumont to Port Arthur Highway. The first demonstration will be barehand. 3 Chance hopline tool demonstrators hold a tailgate session before climbing the structure to explain in detail to the men who will assist up on the structure and to the many executives, supervisors, and trainees observing exactly what will take place and in what sequence. A 3-rail ladder is fastened to a standard ladder bracket at the pole top and landed out on the end of the arm, so the lineman on the cold end of the string can get into a comfortable, convenient working position to land the tensioning equipment for picking up the strain and disconnecting the string. The boom pole for handling the insulator cradle is rigged. And another ladder attachment, the same as rigged to the top of the structure, is rigged just above the line of conductors. For this 2-rail ladder, which will be used by the lineman as a platform from which to work at the hot end of the insulator string. The ladder is elevated into position by ground men pulling on a pair of rope blocks. A micro-amp meter is connected to the ladder to measure any voltage that might leak through the ladder, a Chance safeguard recommendation, testing the equipment before it is placed in use. When the ladder monitor is in place, the ladder is swung out in contact with the conductor, and the lineman makes one last check for leakage before going out into working position. In the design of these structures, consideration was given to the requirements for proper maintenance of the line and available tools with which to do the maintenance. A standard yoke is landed in a predetermined position, a plate at the end of the arm. The insulator cradle comes up into position on the boom pole with the hot end yoke and one strain carrier pole attached as one assembly. thus facilitating the landing of the yoke in position on the conductor yoke plate. Now, the lineman out on the end of the ladder bonds his barehand conductive suit to the vertical bundle conductor and pulls himself into working position to land the dead end yoke in place on the triangle conductor yoke plate. And the yoke is landed into position. Now, the second strain carrier pole is passed out to the lineman on the ladder, and he attaches it to the hot end yoke. The lineman on the tower doing the same at the cold end of the dead end assembly, and takes up enough slack in the string of insulators so that the pins can be removed. The cold end of the insulator string, or the tower end, is unhooked first, and the lineman on the hot end then places a shunt between the conductor and the first insulator in the string. And the hot end of the insulator string is disconnected from the conductor yoke plate. The second stage of this maintenance demonstration utilized much of the same rigging, but instead of working the hot end of the dead end assembly bare hand, hot sticks are used to get the hot end dead end yoke into position on the conductor yoke plate. The yoke is pulled in between the conductors and landed on the conductor yoke plate. The dead end tools are suspended from the cradle and boom pole assembly. Now that the dead end tool is in place, the second pole will be added and the insulator cradle swung into position under the insulator string, with the hooks of the cradle inserted between the bells of the string for security. On the hot stick job only, the shunt, or static ground, is clamped to the cap on the back bell of the string with 6 feet of number 4 grounding cable connecting a tower ground clamp secured to the tower. This to drain off electrostatic charges in the insulator string after it has been disconnected from the conductor. The insulator string is then elevated by raising the boom pole with a chain hoist and swung into the tower arm for replacement of damaged bells in the string. The string is then lifted away. In this case, swung over to the man on the structure arm for replacement of bells without removing the string from the cradle. Now, we move from the dead end structure to the straight line H-frame structure. The job is to replace damaged insulators on the center string of this steel structure, and we'll do the job by the hot stick maintenance method. A rope is passed from one pole top to the other, and a rope pulley is used to put the tension tool into position over the string of insulators. A set of blocks is used to lower the tool onto a tab of this plan maintenance structure on the top of the arm, providing a positive locking position for the cold end yoke of the tension tool. 2 sets of conductor strain carriers are used, with a hook engaging each of the conductors, thus equalizing the strain on the conductor as the lineman takes up tension. The cotter key is pulled, and the suspension insulator tool is made ready to install on the trolley pole as the strain pole clamps are secured in position on the conductor. The suspension insulator tool cups the third insulator from the top in this string, allowing the ground man plenty of clearance for leverage and freewheeling the string. The cotter key is now removed from the top insulator, disconnecting the string. And the string is trolleyed in to the men on the structure for replacement of damaged bells. After replacement of damaged bells, the string is returned to its position on the structure. The top bell is hooked up, The pin is driven home. The hot end of the string is reconnected to the conductor. The tools are removed and the repair is completed in short order with little effort. On the same structure, we will hot stick the inside V string of the outside phase in an unconventional manner. Rather than using a cradle for the insulators, after pulling the key and taking up the strain on the string, 2 insulator forks were used to lower the insulator string down to the structure for removal and repair of damaged bells in the string. This method worked exceedingly well and saved a great deal of time. Pushing the string back out into place and reconnecting it proved to be no more a problem than disconnecting it. The outside V, opposite the string we just worked, requires that a man be placed out at the end of the arm to handle the tension tools required for hot sticking this string. Through planned maintenance requested by Gulf States Utilities in the design of the poles, the steel pole engineers consulted with the tools engineers of the A.B. Chance Company on the application of existing tools to be used on these structures, thereby holding down costs. Standard steps used in climbing the structure were designed into the end of the arm for the purpose of supporting the ladder which the lineman will work from, thus providing excellent working facilities with standard tools, with only a small modification to the design of the structure. After the ladder is placed in the ladder bracket at the top of the pole and tightened, and resting on the brackets at the end of the arm, the lineman can go down the ladder, maintain all the clearance necessary getting into position. A tab for the cold end yoke, similar to the other tabs on the structure, is also welded to the arm at this work position, and the yoke is quickly landed and secured, directly in line with the insulator string. With the bracket in place, the strain poles are added to the tool set. As in the previous hot stick applications, conductor hooks, padded to prevent scarring the conductor, are added to the strain poles, measured for approximate distance, adjusted and placed on the conductor, one pole at a time, but quickly and easily from the relatively comfortable working position atop the structure. And the padded conductor clamps are tightened. We'll use an insulator cradle on the outside V for easier handling of the string. A bail hook is attached to the cradle to lower the string to a vertical position. The cotter key is pulled, sufficient tension is now taken on the conductor bundle to swing the string of insulators away. The string is freed from the insulator cradle, and ground crews use snatch blocks and plastic rope and a capstan to lower the string to the ground for repair and replacement of damaged bells. You will notice 2 wire tongs from the structure out to the bottom of the bundle conductor. It was considered opinion of our crew that the conductor yoke plate would roll down when the pin was pulled, placing the plate out of reach of the string for reconnecting. The wire tongs hold the conductor in place to prevent this. As it turned out, the precaution was not necessary. We eased up on the chain hoists, holding the wire tongs in position to observe the results, and learned that the bottom conductor of the bundle was holding the assembly fairly even. This would not have been the case with a single conductor. A day's work is done. Thanks to Gulf States Utilities' insistence on planned maintenance being engineered into the design of the lines, the job was easy.